Hello, in this video we'll learn more about the risk mitigation and the controls or methods carried out to minimize the risk. First we'll cover a few key terms. Accountability. In order to maintain accountability, an organization or individual must have the ability to trace back an operation to a certain user, device or location. Without that ability to do so, the organization doesn't have any accountability. Auditing. This involves the manual or technical assessment of an app or a system or data or any IT infrastructure to ensure its integrity is intact. Monitoring. This involves collecting and analyzing information from devices or network to detect suspicious behavior. We'll be covering the information technology control now. IT control, in short, is a procedure or policy in place to provide a reasonable amount of assurance that an organization is in compliance with the laws and regulations to maintain its data or network integrity. Now there's control categories in it. There's three types. First, there's the administrative or procedural control. This involves the use of policies to restrict access to sensitive information. Only authorized employees can access this sensitive information. Technical control. This control involves the use of automated protection to secure the IT infrastructure. Use of firewalls, antivirus, and biometric authentication is an example of technical control. And lastly, there's the physical control. This involves the use of security measures designed to deny unauthorized access to secured locations. This is more physical. The use of fences, CCTV surveillance, and hiring guards to patrol the premises serve as a physical control. Now we'll be covering the control types based on functionality. Primarily, there's the deterrent controls. These controls are intended to discourage potential attacks. It involves use of warnings. Let's say if someone tries to access sensitive info without the proper authorization, then a warning pops up, letting the employee know that they weren't supposed to do this. It deters the action, and hence it's called the deterrent control. And then there's the preventive controls. These controls are intended to prevent an attack in the first place. And then there's the corrective controls. These controls are in place to fix or undo the damage to IT infrastructure after an incident has occurred. Countermeasure. What is a countermeasure? It's an action or method applied to avert or prevent and reduce the threats to IT infrastructure. Antivirus and firewalls are an example of countermeasure. It's used to prevent malwares or unauthorized traffic to go through. Defense in depth or layered approach. In defense in depth or layered approach, it includes the use of multiple layers or barriers of security controls in place in order to protect the integrity of information. IAM, Identity and Access Management. Now what is this? IAM basically it involves identifying, authenticating and authorizing certain individuals to have access to systems or networks. It's about ensuring the right users have access to right resources at right time for right reasons. It authenticates who the user is and then it authorizes them. Central user repository, it contains all the data, and user management, it contains a list of users. Now authentication, it can be done by two methods. First, it's the password and the use of biometric systems, or you could use multi-factor authentication. Moving on, then there's a patch management. Patch management involves acquiring, testing, and installing patches to fix bugs and remove vulnerabilities in a computer system. Now, what are the tasks of the patch management? First and foremost, maintaining accurate info of available patches. Then you have to be able to decide which patches are appropriate based on the device types. Then making sure that patches are properly installed. Then you have to run some tests, system testing, and then all these steps have to be documented. These are the patch management tasks. Now, system hardening. System hardening is a collection of tools, techniques, and proven practices to reduce system vulnerabilities. Now, what's the purpose of this system hardening? System hardening is carried out in order to secure the system by minimizing the attack surface, by eliminating or reducing vulnerabilities that can be taken advantage of. If there are no vulnerabilities to be taken care of, then it gets really difficult for an attacker to come up with a really creative way to hack into the system or network. So system hardening is a vital step in reducing the vulnerabilities. System hardening activities include the following. It includes installing the bug fixes and security patches on time, and keep monitoring the security forums. You have to see what sort of threats are out there. And then closing certain system ports, the server ports, for example. And then denying the file sharing between programs, installing antivirus and anti-spywares, creating strong passwords, and removing unnecessary programs and user accounts. Last but not the least, use of encryption whenever required, so that the data is protected. Change control. Change control is a systematic or organized approach to manage and keep track of all changes made to a device or network. What is the purpose of this change control? It's to make sure that unnecessary changes aren't made and to document all the changes that are made. It's also to prevent the unnecessary disruption of services and to utilize the available resources efficiently. The change control flow is as follows. First, a change request is planned. Then a formal RFC is filed. This formal RFC is approved. It's reviewed by the change approval board. And then when it's approved, it's implemented. And then once it's implemented, it's reviewed again. And then if it's good, it'll stay. Or if it isn't, it'll roll back. And then new changes could be made again. As time goes on, changes have to be made. Now we'll be covering the asset management. Asset management is the systematic process of acquiring, operating, maintaining, upgrading, and disposal of assets in the most cost-effective manner. First, we'll begin with the procurement of assets, and then it will be deployed, and then these systems, IT infrastructure, have to be maintained. And in order to maintain it, you will need the proper support, let it be the hardware requirements or from the company itself, the software requirements. Lastly, when the IT assets get too outdated and when it isn't worth it to maintain it anymore, then the devices will be retired and disposed of. This is the asset management lifecycle. Now we'll be covering the data management. To begin with, what is data? Data is the smallest piece of info in any form. It could be a document, image, or text file, or a software program. And data management is the administrative process of acquiring, validating, storing, protecting, and processing the data to ensure availability, accessibility, and reliability of data for its users. There's three basic states of data. First, it's the data at rest. Data in database, it's the backup data. And then there's the data in transit, when data is moving, when data is being sent over a network or transferred over devices. And then lastly, there's the data in use. That's the data that's currently being processed, actively changed. And then there's the information lifecycle. First, it begins with the acquisition. It involves the index system data, and then the data is used. And then while it's in use, you have to make sure it isn't tampered with. And then the data, as it's updated, once it's updated after you use it, you have to archive it, create backup, and you have to protect this backups and store it for a certain period. This period, it's known as the retention period. And lastly, when the data is outdated, it can be disposed of. It's the disposal. And this data should be destroyed correctly. There's something known as dumpster diving. That's how people get access. Attackers might get access to sensitive info if the data isn't destroyed. There's a certain procedure to dispose it of in the right way. Moving on, data classification. Now, what's data classification? It's an ongoing process. Classifying the data helps indicate the level of data protection. The classification level must be attached to the data or information lifecycle. Restricted data, it includes highly sensitive information. Confidential means sensitive information. Internal, it's non-sensitive information that is not released to the public. And then there's information that's approved for public access. Moving on, encryption. Now, what is encryption? Encryption is the process of converting data into an unreadable or encrypted form to protect the sensitive data. This data can be decrypted or converted into readable form with the right key. Basically, you lock it, and by locking the data, you convert it into an unreadable form. And the only way you can unlock it, that is convert it back into readable format, is with a key. Cryptography. Cryptography is a method of storing and transmitting data in a form that only those it's intended for can read and process. It's similar to encryption. Cryptography protects information by converting it into an unreadable format or a ciphertext. It involves creating written or generated codes to keep the information secret. Only those with the right key or code can decrypt a ciphertext. Basically, what you do in cryptography is you disguise the information, and only the intended person with the right key can get past this disguise and see it for what it really is. Moving on, there's certain factors influencing the effective encryption. First, it's the algorithm strength, the secrecy and difficulty of compromising a key. And then second, it's the existence of backdoors. Compromised network or devices, let's say if someone were to have a keylogger and it compromised your device, then what good is encryption if the attacker can capture the key and decrypt it later? And then it's the inability to decrypt entire ciphertext or message. In some instances, encrypted data can be partially decrypted if the algorithm isn't strong enough. Moving on, there's different types of encryption, symmetric and asymmetric encryption. What's the difference? In symmetric encryption, we use the same key in encrypt and decrypting ciphertext. Symmetric encryption uses less computing resources and it involves sharing a key with the receiver. Whereas in asymmetric encryption, we use two different keys, one public key to encrypt and one private key to decrypt. However, asymmetric encryption uses more computing resources, but it's more secure. In asymmetric encryption, there's no need to share key with the receiver. Now moving on, we'll be covering the incident response. Now what's the incident response? It's the organizational approach to deal with the aftermath of a security breach. Here you'll be dealing with a fallout. That's the incident response. Now what's the goal of incident response? It's to figure out the extent of damage caused and to minimize the damage caused by the incident, to minimize the recovery time and costs associated with it, and managing the potential disruption to IT service. You have to make sure that the IT services are back online and secure as soon as possible and ensure the work environment gets back to normal. Moving on, security training. The objective of security training is to bring awareness and empower employees to reduce risk and lower the likelihood of a potential incident. For an IT infrastructure to be really secure, everyone has to follow some basic rules, guidelines to ensure that the vulnerabilities or risks associated are reduced. And that's the point of security training. Now we'll be going through the key takeaways, what we've learned so far. We learned what information technology control is and its types and categories. We learned about the layered approach, incident management, incident response, and security awareness. We learned about the patch management, data management, and asset management. We also learned about the system hardening, information lifecycle, encryption, cryptography, and types of encryption. So by now we've covered the cybersecurity threat mitigation. I hope you found this video useful.